Hello, hello. So we are, for those watching the recording, we are Laurent and I here today on the SIG meeting, and so Laurent had a really good update from Microx to give us today. So yeah, please, man,
Yeah.
introduce what you have.
Hi, everyone.
Thanks for presenting, by the way.
Thanks very much, Fran. Hi, everyone. Thanks for watching the record. So just tell you a few words about me to introduce myself. So my name is Laurent Broudoux, and I'm the founder of the Microx.io project. This is an open source project dedicated to API mocking and testing. A few words on my background. I work as a solution architect at Red Hat on daytime. On nighttime, I am contributing to open source projects, of course. And I'm a specialist on the cloud native application design. And before that, I was working at customers, mainly on financial services, where I laid some SOA, service-oriented architecture transformation. It was 10 years ago or something like that. And I was deeply involved in all the concerns around how to deliver faster. So here's the initial idea about Microx. Okay, so just before starting the demo, let me share my screen and just telling a few words about Microx. Okay, it seems like I'm not able to share my screen. Will you allow that, Fran, please? Yeah, perfect.
You should be able now. Okay.
Okay. So looking how to share my whole screen, because right now I can only select window, an application. Okay, no problem. I start with this window. Okay, so now you should see my Chrome browser right now. Okay, so a few words on Microx. So as I said before, it's an open source tooling. It is it is all related to Kubernetes and dedicated to API mocking and testing. And we just launched, it was during August, the 1.0 release, okay? And there's two big features around Microx. The first one is obviously around the mocking. So basically, Microx allows you to turn any API specification, any API contract, whether it's a Postman collection, an Open API specification, and of course an Async API specification. It allows you to turn that into live mocks in seconds, so that the consumers of your API may start working immediately. They do not have to wait for you to develop the API implementation, so that you can speed up your delivery and start development as soon as you have written your API specification. So this is the first big feature. The second one is about testing. So we are able in Microx to reuse your API specification, your Postman collection, and then use it as some test definitions, so that once you have deployed your API implementation, Microx is able to check that this implementation is compliant with your specification, okay? And we provide different plugins, different CLI tools, so that you can integrate these checks into your automated CI/CD pipeline. Okay, so we provide, for example, a Jenkins plugin, and we provide some simple CLI and also a Tekton task. Tekton is the new cloud-native CI/CD technology right now. Okay, so as I said before, we announced the support of Async API. It was during this summer on August. And now we should have, it will be for the end of this week, we should have the 1.1 version that come and that brings some new features around Async API. So basically for the 1.0, we provide already everything about around mocking Async API. And now with the 1.1 version, we provide anything for testing your Async API implementation. Okay, so let me show you how it goes. First, I have deployed a Microx installation onto my Kubernetes cluster. So right now, this is an OpenShift cluster, but basically it works on any Kubernetes distribution. Okay. And Microx is just a set of microservices. So depending on the features you want to enable to disable, you will have different deployed microservices for Microx. And if I'm connecting to the application, this is the home screen. This is the dashboard. Okay, when I can easily have a look on my API and services repository. So this is the number and the different kind of API I have in my registry right now. Okay, there is 2 APIs for now. I have also some analytics, some statistics about the most used APIs and so on. So basically, how you can add new APIs, how you can add new services to Microx is fairly easy. You've got this concept of importers. So basically, you tell Microx how to connect to your Git repositories, to your enterprise repository, and it will schedule some imports, or it will react as a webhook, okay, and it will download the specification and discover the specification. Here we can see that we have 2 APIs. One is about the registration of a user, and another is about, it is an Async API, of course, and it is about the signed up event that we may send when a new user is registered, for example. Once these API are imported, they appear in the registry right here. So you've got these nice pictos here and different colors telling you this is a REST API and this is an event-based API. So you can use labels so that you can have your own taxonomy to easily classify and then retrieve your different set of APIs. Okay. So when I go to an API, user-signed API, okay, I've got the basic informations right here with the contract of this API. And you can see that it has discovered the different operations. Here, there's just one operation, okay. And because I have enabled all the asynchronous API support in Microx, I can see that this Microx is connected to a Kafka endpoint because my Async API has a Kafka protocol binding, of course. Okay, it has found different examples. The specification was defining 2 examples here. And as soon as this API specification is imported into Microx, it starts publishing example messages on the endpoint every 10 seconds. So this is the default frequency. You can tune it, of course. The different messages will be published on a specific topic. that is created by Microx at the API import. So the first thing is that I can check that everything is now okay. I have to share up my terminal, okay. And now you can see my terminal right here. So just using a simple Node.js consumer, I can see that each and every 10 seconds, the Microx server is publishing new messages from the examples that were found into the specification. Okay. So basically, that was the feature that the 1.0 release brings. And now we have added some new feature around the tests, of course. Some right here, you can see there's a little diagram here, giving you some results of the last test.
Laurent, so we cannot see your browser now. You have to share your browser.
Yeah, I switch, no problem. Okay. So right here, you can see there is this little diagram here. And the nice thing about the next coming version is now I have the ability to launch tests to connect to a real Kafka endpoint somewhere in the organization and to check that the different messages that are published on a topic are compliant with the schema information that were provided into the Async API document. So just I can access the history and just copy paste here. So basically from the UI, I can launch a new test. Okay. So my service under test, my API under test is the user signed up API with this version. And I just have to specify a test endpoint. So a test endpoint, because I use a Kafka broker, it is starting by Kafka. Then this is my host and my port, and then the topic name. Okay. For each test in Microx, I have to choose a runner. For Async API, there is just one runner, the Async API schema runner. And I have some advanced options. I can select, just put a timeout right here. So if I start a new consumer on my terminal, okay, I'm starting to produce messages on a topic, and I can launch test here. I see that a test is running. It is listening to the topic, and okay, it should end, and there is a failure. Okay, I can see here that I received one message on this topic, and this message is not compliant with the schema. So I'm able to go to the full results here. Just have the payload of the message that was received and the validation error regarding the schema. So right now there is a problem because we find an integer here and we were expecting a string for this this property. Okay, so it's normal we have a test failure. So just switching my window.
Just one quick question.
Yeah.
If I may. Sorry for interrupting.
No problem.
So this where's this data coming from? This data is coming from the mocking, right? The data that you know, with your name, your age, your email.
This data?
Yeah.
This one? No, here, this is the data that is sent by my implementation. So
okay.
Imagine I have developed an application that should publish this event with Microx, I can listen to the topic this application is connected to, and then I will check that the events sent by this application are correct. So
Okay. Makes sense.
This is real data coming from the real application.
Okay, so this is real data, let's say.
Yeah. So let's now imagine
Thanks.
I'm fixing the application, okay, and I can just relaunch the test, okay, getting back here, starting with a new test. This is this runner, okay, no advanced option required, launching test, and just right here. Yeah, this time it's correct. And if I check the full results, I can see that now my application is sending a correct message where the send_at property is now a string and not an integer. So basically, this is how we can easily test application that should produce or consume events using Microx and all the information present into the Async API contract.
That looks really cool, man. So I just have one question here.
Yeah.
That comes to my mind is, I guess this is for testing environments and not for production, maybe. Because I'm thinking, so the reason I'm asking this is under huge loads, let's say, of messages, when you have a lot of messages in production, then you will also have to scale Microx to handle this amount of messages, right?
Yeah.
So,
right.
So what's your point of view here? Like, this should be done on test, on production, and both?
Yeah, so obviously it should be done as early as possible into the development process. So we recommend plugging Microx starting from the dev environment, but there is nothing that prevents to use this with the production test. As soon as we are able to connect to the remote endpoint, and we can easily manage that using this ability here to specify some secrets, so that I can reuse credentials, I can reuse certificates to connect to each and every broker into the organization. This is not a problem. Regarding all the scaling concerns, and that's the nice thing about being based on Kubernetes and having an operator that is managing all the life cycle of the Microx installation. This is something we are starting to implement with the operator. So basically, what we have planned is if your installation is tending to have more and more tests in parallel, is starting to listen to more and more different endpoints, the operators will be able to scale the number of components, scale the number of consumers within the Microx installation, so that it should not be an issue.
So then I'm not a Kubernetes expert, actually. Like I'm new almost new at Kubernetes. So so the way you're seeing this is to have Microx like in a centralized place where all your microservices are going to publish or subscribe from to, well, actually publish in this case only, right? So is this the let's say the architecture design that you are I don't know how to it's not that you're offering, but that you're suggesting here that you have Microx installation in a place, and then all your microservices, or at least a big set of your microservices, like a domain, if you want, are going to be published into this Microx instance. Is this the way it will work, or it's working right now at least?
Indeed, there's yes, it's a mix of many things. So it comes with Microx comes with opinions, and my first opinion was that I've tried before in the past, but having each and every developers managing mocks on their sides, on their laptop, on their pet VM or something like that. I've tried this before, and I've seen many customers trying this. This approach is not very scalable when you when you're starting to have dozens or hundreds of services and APIs. This does not scale because you always have some issues around synchronization and keeping everything up to date. So you ended up having different developers working with different mock definitions, and that's led to chaos, obviously. So the first opinion with Microx was to providing some kind of a platform so that developers, different teams do not have to worry about running their own mocks. They can rely on the Microx installation that is shared, that is always up to date. And this is because this is why it is important to be connected to the Git repository. And it provides mocks and the same mocks for everybody. So this is the first opinion. But that said, and because we rely on Kubernetes, on operators, it's really easy to set up, to initialize new Microx instance. So we are starting to see customers having starting with one instance for all the needs related to development, and then they start popping new installations for example, creating a new sandbox for partners, or creating a new sandbox to use during performance testing, so that they can simulate a different response time on their API using Microx. And then they are using some features. We have some abilities around exporting and re-importing mocks definition between different Microx setups. So actually, it's definitely, Microx is definitely built as a platform, but it's really easy to have different instantiation of this platform.
Nice. No, that's really cool. Just wanted to know more about. Actually, you have it there on the Red Hat OpenShift.
Yeah.
On the tab, on the browser tab, you have it there. It's the topology, right?
Yeah.
So I was meaning the topology. I couldn't find the word. So and again, I'm like pretty new to Kubernetes. So have you thought about having this as a I think it's called Sidecar, like having like each service have to have a Microx instance, mini Microx instance, obviously, as a sidecar, and then the information is somehow centralized in some place. So I'm saying this because in case of scaling, in case you want to scale this, and one service is behaving like a beast and it's publishing a lot, then only this Microx instance is going to be affected, right? And the rest are going to be fine. Just from time to time, this instance will have to update the results, let's say, of the Microx tests and mocks as well, on the central place, let's say, right? So I don't know. I think, have you considered this, or maybe you considered this and you thought it was a bad idea at all?
No. The sidecar-based architecture is really interesting. It opens the door to many use cases. So currently we are exploring some usage of the sidecar pattern with service mesh, for example, because there is when you want to use some of the features in service mesh, like for example A/B testing, like mirroring the traffic, like for example during canary release, you can easily imagine how a Microx can be used to gather the real traffic of an application, or to be used as a placeholder waiting for a new feature to be developed. For example, you may introduce a new version even if it is not yet deployed, developed. The sidecar will use the mock provided by Microx, for example. So definitely this is something we are exploring. The sidecar patterns may open up the door to many new use cases.
I'm saying cool. I'm saying because of this, like it will be great to have, like, for instance, every team, because the whole thing about microservices is not so much the technology, but it's more about how people work, right? How people can manage their own work from design to production, right? The whole way, right? From idea to production, if you want. So I was thinking that maybe, and one of these parts is actually the evolution of the service, like you were saying before. That this will allow people to, for instance, work on version 2 of their service, version 3, right? The next version.
Exactly.
Before and update their sidecar or their Microx instance running in their sidecar that they manage, right? And that will allow them to start, like, already in production, generating mocks and generating tests before it's actually done, before it's actually, like you said, like it's actually implemented. Like this microservice, it's still in version 1, but you already have the mocks and the tests in your instance. So whenever you want to develop, you already have the information there. Or even better, other people relying on your next version of the service that will be relying on that can already start consuming your next version messages, so you don't block them, and they don't have to wait for you until you implement the new version of your service, right? So that will be super cool. And also the reason I was saying that is, so we are, one of our plans at Async API is to have something that well, there's a bit of confusion with the name, but so the current Async API Hub, it's gonna be renamed to Async API Studio, right? So that's one thing, that's one part. And then we're gonna create something which is probably going to be called Async API Hub. And it's probably something like this, something like what we were saying. It's a piece that you can install on your sidecar, or actually as a centralized service in your architecture, right? And that will allow you to validate messages before they go to the Kafka broker, for instance, or before they go to the AsyncAPI broker. So it's actually polyglot proxy, if you want, that will apply certain policies, not only validation. You can validate, you can probably encrypt the messages there. So nobody has to know the secrets to encrypt and decrypt messages, because only the security team will be in charge of going to your sidecar and updating the secrets, right? To encrypt and decrypt your messages. So you will not at development, you will not have to worry about that, right? Only people, only DevOps, if you want, or security people will need to know it. And or for instance, also a transformation, like for instance, you want to make sure that every message has a send at field, and if it's not there, you should be you should be adding this send at with the current date, with the current timestamp, for instance. So things like this, can be stupid things like this, or can be transformations in the sense of we want to start transforming all the messages from version 1 to version 1.1,
Yeah.
right, or version 2. So you do the transformation on the sidecar first, and then so the other services can adapt, and then people can update their code, right? Which this part is a little bit tricky because that will that reminds me a lot to what what was the name, what TIFCO was doing in the 90s. Forget the name.
Yeah, with the business process manager of the business works, TIFCO.
Yeah, but there is a name for that. I don't remember. Anyway, so that goes against the philosophy of microservices, where you have smart endpoint dump pipes, right? So
yeah, exactly.
there you will have a little bit of smart pipes a little bit as well. So yeah, we're still figuring out but I mean, that's in our case, that has to be unopinionated. Like, it's not a product, it's just a technology piece. You use it as you want, because you might not be doing microservices at all.
Yeah.
So yeah.
Yeah, for sure. Yeah, we are seeing users of Microx using it not for REST APIs, not for Async APIs, but for legacy SOAP web services, because we are also able to mock and test SOAP web services. So people use Microx, for example, during a technical migration. They are changing their ESB. They are switching from TIFCO to whatever.
ESB. Yeah, ESB. That
ESB.
is what I was saying.
And they are using Microx to secure the migration effort, indeed. And this is not related to microservices, to API, but pure old SOAP web services. They are using Microx as well.
Okay. Yeah, other let's say kind of architecture that people tend to use with Async API is task queues, right? So people start queuing tasks in, for instance, in RabbitMQ, for instance, right? Yeah. That's very common. Like, people, one common example is queuing emails, right? Like, not just emails, but for instance, you queue a welcome email, or you queue an email saying like, hey, you registered, you signed up, but you didn't complete step 1 or 2 or 3, whatever. You have to give some time to people, right? That's why you queue it there. And so this kind of things are also asynchronous, let's say, operations, right? With AMQP or asynchronous APIs or events, if you want. But yeah, they are not microservices at all. Like, this can probably be a monolith with just a queue, right? Yeah. And I'm saying because I did it in the past. So I've been working with this architecture in the past, like a monolith and a queue.
A queue, yeah.
So yeah.
Okay,
that's cool. That's cool
thank you for the transition. And here's the last piece of the demonstration. So right now, imagine you have this kind of maybe monolithic application regarding user registration. Okay, so it is deployed here into my Kubernetes cluster, and it has its own Kafka broker. This is not the Kafka broker used by Microx internally. This is another Kafka broker. And this application right here just expose 2 APIs. The first one being the REST API, allowing a user to register, okay? And the second one being the user signed up API, because the business rule is when you have registered a new user, you should publish an event to say this user has been signed in. and as you say, to send him an email to compute some discount advantages or whatever. Okay. And one nice thing with Microx is that you can, all the tests we have done before, you will be able to automate this from your delivery pipeline. So for example, right here for this application, imagine I can write some kind of pipeline like this. Okay, so this is a Tecton pipeline, and basically it has two branches. So I start with building the app, deploying the application, and then I will have a first branch that will take care of testing the OpenAPI REST API, the registration API. I can test it in version 1, in version 2. And then I have a parallel branch that is taking care of gathering the messages and testing the Async API specification. And then if the two branches are okay, I can say, okay, this application is implementing the two APIs correctly, and I can promote it. So if you have a look, sorry, I start hating YAML, but if you have a look at this YAML pipeline, right here, you've got this task here that is Microx test. So here I can specify the test endpoint, I can specify my broker that is used, I can specify the secret that is used to connect to the remote endpoint, and actually the different test steps here are all Microx tests. So if I'm simulating a pipeline run, if I'm running a pipeline, I can deploy the application, and then the Tecton pipeline will take care of calling Microx and asking Microx to test these APIs. So should be okay right now. Wait a second. Okay, so the tests are good. And if I'm going back to my Microx service definition, I can see that there is a new test right here. So the test number 12 was run a few seconds ago, and it was the one that was launched from my pipeline.
That's really cool. So that's I assume that when you launch a test before promoting the app, let's say, when you launch a test, it has to wait for the data to come, right? Like for instance,
yeah.
So the data that you're feeding into the test is real data, like it's coming from the real application.
Yeah.
If that's the case, what if no messages are coming? Like for instance, there are some kind of applications that are not data intensive. Like for instance, they get some messages every day, not every minute, right? Like every day. So what about them? Like what about this case?
Of course, if there is no data coming, the test is failing. But right here, indeed, because in parallel we are invoking the REST API, we know that the expected behavior of the application is when the REST API is invoked, it must publish a message on this topic.
Oh, yeah.
And on the other branch, we are just listening for this message. If this message is never coming, the test is failing.
Okay. Yeah, and because you're calling the test on the REST API, a message to actually come.
Yeah.
Okay,
So
I see what you mean.
Using the combination of delivery pipeline, CI/CD pipelines, whether it is Tecton or Jenkins, whatever, and parallel branching and Microx tests, you have wonderful mean of actually testing that the interface of your API are correctly implemented, but also that the behavior of the application is correct, because you can test in parallel the synchronous part and the asynchronous part, making a condition that both parts will join before promoting the app.
That's really cool. So I guess there is some kind of order here, right? Like you have to first test the OpenAPI part here, then you, or at least, well, order is not enforced, but at least the timeout on
yeah, you have to
yeah.
you have to set some some coherent timeout, because if you are just waiting on this Async API branch for 2 seconds and your application has some kind of warm-up timeout before actually publishing message, it will fail. But
yeah,
just tuning the timeout is really okay.
I guess that's Tecton related, right? So it's not really Microx. So to define these details, something from Tecton, or
no, this is Microx, because on the different plugins and tasks we are providing. Oh, sorry, let me go to the pipelines. On the different tasks we are providing, there is this specific attribute wait for, and indeed, yes, the async part is waiting longer, 20 seconds, and the OpenAPI, the synchronous 8 seconds. Yeah, so you have just to tune things like that to be sure to wait the correct amount of time.
I guess it's waiting like 20 seconds at most, right? Like,
yeah,
if it happens before, it will just continue, right? Like, it doesn't have to fulfill the whole 20 seconds, right?
Yeah, of course, yes.
Okay.
Here it has just wait 8 seconds.
Okay, nice. That's perfect. Thanks, man.
Okay, that's it for the demo.
That's really impressive, and you're doing a great job here. It's really moving forward, the mocking and testing of event-driven architectures, and this is super interesting, because I mean, there's nothing, and you know it, like there's nothing about it. There's nothing yet to test and mock aside from Microx. Like there's nothing else to test event-driven architectures, and that's super important step if we want to make event-driven architectures as mature as REST APIs and let's say microservices architecture based on service mesh, or well, yeah, like in a similar, like mature in a similar way, right? That's my point. So right now we have lots of tools for REST APIs, for service meshes, for many things.
Yeah.
For many synchronous things, let's say, but for asynchronous stuff, we have almost nothing, right? Like people were historically trying to avoid this kind of architectures because it is complex. It is complex to reason about and to implement. And with these tools, we're actually making it easier to succeed on event-driven architecture. So that's impressive.
Yeah,
and I got a note on what you said before, and I think this is really important, and people are not yet exploring this area so much, is about offering like a sandbox for your partners.
Yeah,
this part to me is going to be key in the future. So like offering real-time integrations to your partners. So your partners don't have to be calling you all the time. Instead, you will feed the data directly to your partners when something happens. Right?
And also you do not have to maintain expensive environments for your partner. I met quite a few customers that were starting evaluating Microx, And I was very surprised when they told me that they were having a full representative environment for stuffs like open banking, for example. Some banks are providing open banking services, and they are dedicating a whole environment to the sandbox they provide to partners. And they say that it's really expensive because they have to maintain all of this. They have to feed this environment with representative data. They have to pay licenses, software licenses for everything. And they are starting looking really closely at Microx to replace everything by just a sandbox with a bunch of contracts and the set of correct examples, so that they can open that to partners as well.
Yeah, that's true. And I'm like you know, cost is an important thing here, but I'm more interested in the business facts. Let's say like right now, the way we implement this with partners or consumers or our external consumers in REST APIs, it's clear. It's like you give people, you have OAuth 2, for instance, for people to authenticate and consume your data, your real data, and that's on demand. So when the user needs it, you reply, and then you have, of course, you have to apply limits, rate limiting, and all this stuff. But we found, or I found in the past many times that I wanted a higher limit, rate limit, because I had to ping the API very constantly, like because it was impossible for me to wait more, because I wanted something more real time, but I couldn't because the API wasn't offering this to me. We now have some, well, not now, but we started to have this webhooks architecture, right? So it's actually the company or the API you're consuming is actually calling you, right? So it's a step, right? It's now a step towards asynchronous operations, let's say, if you want. So, but that's cool because let's say this is that's cool because you don't have to ping the API all the time, but it's out of band. And what's happening here is that if, of course, there are retries. If your services are down for whatever reason, and the webhook is calling you many times, after a certain number of retries, you're gonna miss this data, right? Of course, you shouldn't have your services down. That's you take it for granted, but these things happen. So so in my opinion is, if we can queue, let's say, if you can queue this data somewhere, like in Kafka or in a routing queue or something like this, and then it's actually myself who I'm gonna go there to the queue and consume the data whenever I'm ready, right? Whenever I'm up and ready, or even in the case of Kafka, I want to go back to the history of data, and replay for whatever reasons, because I want to do it. Why not? Or I need to do it, and without affecting a lot to the load on the provider service, right? On the provider side. So this kind of integrations between third parties, let's say, I think this is an interesting area to explore in the future. Because right now we're always, whenever it is about third-party integrations, we're always thinking REST APIs. REST APIs or GraphQL APIs, or it's always synchronous. It's like, why not real-time integrations? Why not handling this to the user, right?
That's where I think the Async API has a great role to play, because one major issue when you start talking with partners about asynchronous integration is usually there is two main problems I see. What is the protocol, And do you have some kind of industry standard protocol that offers loose coupling? So Kafka is now the de facto standards, but some other players like AsyncAPI are really portable protocols. And the other issue I usually see is around how to specify, how to describe the contract. And this is where Async API specification should have its role to play. So I think right now we do have the tools to make asynchronous integration rise.
Yeah,
it's
exactly.
up to you. It's up to us.
It's up to us, exactly. Yeah. It's up to us to provide better tools, to provide better documentation, to provide use cases, to provide more information in the end. Because it's more than tools to me. Is a mindset change, right? So
it's also a mindset, and all the things around CI/CD helps a lot because people start to think, start to ask them how to do things in a more agile way, to deliver software more in a more fluid way. So it's the good time.
What a good time to be alive.
Yeah.
Cool, thanks, Laurent. So I hope I'm pronouncing well your name.
Yeah.
It's Laurent.
Yeah, it's great. No problem.
I was calling you Laurent.
No, I'm used to Laurent also because I have a few Spanish friends, so I'm used to that.
Lorenzo, you will be Lorenzo here in Spain. Cool, man. So thanks for joining us today and giving us this cool demo. This Microx thing is, I think it's going to have a great feature, and I hope it's going to have a great feature. And always happy to have you share the updates.
Yeah, thanks a lot for having me. It was really nice talking to you. Yeah.
Thank you. You're welcome. Okay, so I'm just closing the recording right now. And for those who don't know, we are having this meeting every 2 weeks. So in 2 weeks, but we're alternating times. So in 2 weeks, we'll have the meeting at, let me see if I can see it, if I can say it correctly. So next meeting is going to be at 4 p.m. UTC. So it's actually 5 p.m. In Central Europe time. So this is more America friendly if you want. And then in 2 weeks later, we'll have the meeting at this time again, which is at 8 a.m. UTC. And this is more Asia, New Zealand, Australia friendly, let's say. I think, what was the name again? It's APAC, right?
APAC, I would say.
APAC friendly. So yeah, this is an open meeting, so feel free to join. Thanks.
Thanks. Bye.